Welcome to Module 1 of our Introduction to Ethereum course. Over the next few minutes, we're going to build a rock-solid understanding of what Ethereum is from its first principles. By the end of this module, you'll understand what blockchains actually do, why decentralization matters, and how Ethereum solves real problems that affect billions of people every day. Let's get started. What is a blockchain? Imagine a shared Google Sheet. You know those spreadsheets that multiple people can edit in real time? But instead of it being controlled by Google and stored on their servers, this spreadsheet is copied across thousands of computers. And here's the crucial part. Anyone can verify the entire history. No single person controls it. That shared spreadsheet, that's essentially what a blockchain is. When someone makes a change, adds a transaction, or records a transfer, that change is recorded permanently. Everyone on the network agrees on the new version. And critically, the old version cannot be secretly modified later. Notice on screen how each block refers to the previous block's hash, like a cryptographic fingerprint. If you try to change block 1, it would change block 1's hash, which would break the connection to block 2, which would break block 3. The entire chain would become invalid. That's why it's so secure. Let's break down the terminology. There are 3 concepts that make a blockchain what it is. First, ledger. This just means a record of balances and data, like a bank's accounting book, except it's distributed. Second, distributed. That means copies of this ledger exist across thousands of machines, not in one data center, not controlled by any one company. And third, linked blocks. Each block contains transactions, a timestamp for when it was created, and most importantly, the hash of the block before it. That linkage is what creates the chain and what prevents tampering. If you wanted to change some old transaction, you would have to go back and recalculate every single block that came after it. But the entire network holds copies of the true history. All other nodes would then immediately reject your altered version. That's the security of a blockchain. Now let's talk about decentralization, because this is the power of Ethereum. In traditional systems, think of your bank, your email provider, or a marketplace like Amazon. There's one central server. All data flows through it. One company controls it. One company can shut it down, censor you, get hacked, or just disappear. Ethereum removes that central point of failure entirely. Instead of one server, there are thousands of independent nodes. Each one stores the complete blockchain, validates transactions, and executes smart contracts. All of these nodes must agree on the same result. We call this a replicated state machine. Think of it this way. If you submit a transaction, every single node in the network runs the exact same computation. Node A executes it, node B executes it, node C executes it, and they all produce the identical result. If any node disagrees, the network rejects that node. No single company controls this. No single server can be shut down. The system is resilient because it's distributed. This diagram shows the heart of how Ethereum works. You have a current state. This is the complete record of all account balances, smart contracts, and data on the network. Then a transaction comes in. You might be sending ETH to a friend or calling a smart contract. That transaction goes into every node. The EVM, or the Ethereum virtual machine, executes this transaction. Every node computes the same thing. Same input, same computation, same output. This is what we call determinism. It's critical in blockchain infrastructure. Determinism means giving the same starting state and the same transaction, you will always get the same result every single time on every computer, whether you're in New York, Tokyo, or Cape Town. That's how thousands of computers can agree without a central authority telling them what the answer is. They all compute it independently and arrive at the same conclusion. Now let's zoom out and ask, why does Ethereum exist? What problem does it actually solve? For decades, if you wanted to do anything important online, you needed a trusted middleman. You wanted to send money internationally, you used PayPal or a bank. They took a cut. They could freeze your account. They could be hacked. Want to borrow money? You went to a bank. They decided if you were worthy, and they controlled the terms. Want to buy something from a stranger? You used Amazon or eBay. They sat in the middle, controlling the marketplace. The problem is, you have to trust these companies. You have to trust that they won't disappear. You have to trust that they won't censor you or lose your data. Many people around the world, especially in countries with unstable financial systems, authoritarian governments don't have reliable institutions to trust. Ethereum's solution is radically different. With Ethereum, code runs exactly as written without requiring you to trust any company. When you sign a transaction with your private key, no one can fake it. No one can modify it after you've signed it. It will execute in the exact way that you programmed it to. That's the promise. A global execution engine for programmable agreements with no middlemen required. At this point, maybe you're wondering, aren't there any other blockchains? Bitcoin, what about Stellar? And yes, they're all trying to solve different problems. Let's look at how they compare. Bitcoin is often referred to as digital gold. Bitcoin's purpose is to be secure, censorship-resistant digital money. Think of it like digital gold. The consensus mechanism is called proof of work. Thousands of computers compete to solve difficult math puzzles. Whoever solves it first gets to add the next block. Security comes from real-world energy expenditure. Attacking the network would cost billions of dollars in electricity. But this comes with its trade-offs. Bitcoin is extremely energy intensive. Blocks take about 10 minutes and is not very programmable. You can't easily build complex applications on top of it. Ethereum, otherwise known as the programmable blockchain. Ethereum's purpose is to support smart contracts, tokens, and decentralized applications. The consensus mechanism of Ethereum is proof of stake. Instead of solving puzzles, validators lock up the native token of the network called ETH as collateral. Security comes from economic incentives. If you misbehave, you lose your stake. Ethereum is much more energy efficient. Blocks come through every 12 seconds, and critically, it has full smart contract support through the EVM. You can build almost anything on it. Stellar is the fast payment network. Stellar's purpose is fast, low-cost global payments and asset issuance. Their consensus mechanism is called the Stellar Consensus Protocol. Nodes choose trusted validators and consensus emerges from those trusted relationships. Stellar is very fast. Finality in 3 to 5 seconds. Transaction fees are tiny. It's energy efficient, but programmability is limited compared to Ethereum. So which is best? Depends on what problem you're solving. For pure store value, Bitcoin's security model is exceptional. For complex applications, Ethereum's flexibility is unmatched. For fast cross-border payments, Stellar excels. All three are solving real problems. They're just optimized for different use cases. Ethereum has two fundamentally different types of accounts, and this distinction is crucial to understand how the system works. Firstly, externally owned accounts, or EOAs. These are user wallets. They're controlled by a private key. EOAs can initiate transactions, and only EOAs can do this. They represent real people or entities interacting with the network. Secondly, contract accounts. These contain smart contract code. Contract accounts cannot initiate transactions on their own. Think about it for a second. A smart contract can't just wake up one day and decide to transfer your money somewhere. It can't spontaneously execute. Contracts are 100% event driven. A contract only runs code when A user or EOA calls it, or B, another contract calls it. But it always requires an external trigger. This is actually a feature, not a limitation. It means smart contracts can't go crazy. They can't act without being prompted. This is a fundamental security property of Ethereum. Now let's define what a transaction actually is. A transaction is a signed instruction to modify state. And there are three main things you can do with a transaction. You can transfer value, you can send ETH from one account to another. You can call a smart contract function, that is, run some code that changes data. Or you can deploy a new smart contract, broadcast compiled code to the network that will live there permanently. Here are the key properties of a transaction. It's signed with your private key. This proves ownership and intent. No one can forge your transaction. It's cryptographically impossible. And once you've signed it, no one can modify it. It's broadcast to the entire network. Every node receives it. It modifies Ethereum state, meaning it changes balances, data, or deploys code. And it consumes computational resources, which we measure in gas. More on that in a moment. Here's the journey a transaction takes. The user signs their transaction with their private key. They broadcast it to the network. Validators collect it and include it in a block. The EVM executes it on every node. The state updates on the entire network. The beautiful part? Every step is trustless. No one can intercept your transaction. No one can modify it. No one can prevent it from executing except the network itself, and only if it's invalid. Gas is one of those concepts that initially confuses people, but it's actually quite elegant once you understand it. Think of gas like fuel for your car. If you want to drive 100 kilometers, you need to buy petrol for your car. The longer you drive, the more fuel you consume. In Ethereum, computation costs gas, storage costs gas, more complex logic costs more gas. Why do we have this system? Well, first, it prevents infinite loops. If a smart contract had a bug and entered an infinite loop, it would consume gas until it ran out, and then the execution would halt. The contract couldn't crash the entire network. Second, it prevents spam. If transactions were free, someone could spam the network with trillions of useless transactions. Gas makes attacks expensive. Third, it compensates validators. Validators who secure the network are paid in ETH, which comes from the gas fees that you pay. That's the incentive mechanism. Now here's an important detail. Gas is a unit of computational work. ETH is the currency used to pay for gas. If you're sending a transaction and something goes wrong, maybe the contract reverts, execution stops, and you don't get your gas refunded. You've paid for the computation that was attempted, even though it failed. Think of it like hiring a contractor. You're paying them for their time and effort, not for a guaranteed outcome. Let's talk about the engine that makes all of this possible, the Ethereum Virtual Machine, or EVM. Think of Ethereum as a world computer, not owned by any country, any company, or any person, a truly global computer. And the EVM is the CPU of that computer. It's the processor that executes all computations. The EVM executes smart contract bytecode. That's compiled low-level code that smart contracts are converted into. It computes deterministic state transitions. Remember that word, deterministic, same input, same computation, same output. Always. This determinism is the miracle that allows consensus without a central authority. In a traditional system, one powerful computer decides what the answer is, and everyone else trusts that computer. With Ethereum, every node runs the exact same computation independently. They don't need to trust each other. They just compute the same thing and compare results. Here's the process. You start with the current state, every account balance, every piece of stored data. And then a transaction comes in. The EVM executes it, every single node runs it, and you get a new state. This happens thousands of times per day, and the network stays perfectly synchronized because everyone's running the same program on the same data. Let's recap what we've just learned. A blockchain is a distributed, tamper-proof ledger. Data is spread across thousands of machines, and changing the past is cryptographically impossible. Decentralization removes the need for trusted middlemen. There's no central company that can shut the system down, censor you, or take your money. Ethereum solves the problem of trustless execution. Code runs exactly as written. You don't need to trust any company, just the code. Ethereum differs from Bitcoin and Stellar in design goals and consensus mechanisms. They're optimized for different things. Ethereum has two types of accounts, EOAs and contract accounts. Users can initiate transactions, contracts cannot. Transactions are signed instructions that modify state. They're cryptographically secure and deterministic. Gas is the computational cost mechanism. It prevents spam, prevents infinite loops, and compensates validators. And finally, the EVM deterministically executes smart contracts. Every node runs the same computation and arrives at the same result. Putting it all together, here's the big picture. Ethereum is a decentralized programmable state machine. No company needed. The code runs exactly as written. Thousands of nodes keep it honest by computing the same thing independently. That's the innovation, and that's why Ethereum matters. Now that we have the foundations of Ethereum understood, in the modules ahead we'll dive deeper into how to build on Ethereum, how to write smart contracts, and how to deploy decentralized applications.